Hello everyone, this is Wasim from Edureka and I welcome you all to this part 2 live session in which I am going to continue with the demo for AI in text analytics and NLP. So let us take a look at the agenda for this session. Firstly, I'm going to begin with a few text analysis operations using NLP, and then we will learn about a few techniques to prepare text data for modeling. And finally, to sum up this session, we will perform sentiment analysis on a dataset. I hope you are clear with the agenda. Also, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates on Edureka. And do check out Edureka's postgraduate AI and ML certification program. The link is given in the description box below. Now let us cut to the chase and take a look at a few operations we can do with the NLTK, that is natural language toolkit that we have in Python, guys. So first of all, I want to talk about tokenization. So tokenization is the process by dividing the quantity of text into smaller parts, which are also called tokens. And alternatively, tokenization is the process of breaking up the given text into units, which we call as tokens. And these tokens may be words, it can be a number or a punctuation mark even. And tokenization actually do this task by locating the word boundaries. So we'll go to Jupyter Notebook, guys, and we'll see how we are doing this. So first of all, if you are not familiar with Jupyter Notebook, I suggest you to check out our tutorials on how to learn Jupyter Notebook and how you can start your journey with Python on Jupyter Notebook. And we also have a cheat sheet that you can follow. This is quite easy, guys. The interface is very easy. You have all these cells where you can just put out your code and run. So first of all, you have to import NLTK. And because I have already installed NLTK on my Anaconda prompt, I do not have to do it again. But if you get an error like there is no module named NLTK, so just run this command, that is pip install NLTK in either your terminal or your Anaconda prompt, and you'll be good to go, guys. So the first thing that I want to talk about is tokenization. So it is basically two things that we have, which is sentence tokenization, and then there is word tokenization as well. So for that, we're going to need a text, guys. So here I'm just going to provide a string. This is a very interesting quote from Mahatma Gandhi, guys. So I'm just going to take it as the text in which I'm going to do some tokenization. So the first of all, I am going to import a few dependencies for that. So from NLTK, first of all, I have to import sent tokenize, right? And with this only, I'll just get another dependency, that is word tokenize. So now to tokenize this text that we have, this string, what I have to do is I'll just take one variable, let's say a, and inside this I'm going to call sent tokenize, and I'm just going to provide text over here. And let's say for b, I'm going to call the word tokenize and provide text over here. Now when I print a, I have this string divided into smaller parts or smaller tokens. So for my string over here, there are 3 tokens that it is divided into, and we have each token as an element in the list. And when I print b, which is the word tokenization, so each word is an element inside the list, or we can say that each word or even the inverted commas and all those things are a token in our list over here. So this is how you do tokenization, guys. So next up is frequency distribution. Frequency distribution is nothing but, it is basically going to tell you, or it basically records the number of times each outcome of an experiment has occurred. So we're going to do the frequency distribution on this word tokenize only, which is our b variable over here. So first of all, I'll import the dependency from NLTK, and I'm going to import frequency distribution, guys. All right, so no errors here. So now I'll just call my function as frequency distribution, and I'm going to provide b over here. So now when I print f, I have this frequency distribution inside which I have all these elements, and I have the record of number of times they are occurring inside my list, guys. So this is actually a dictionary, basically a key value pair. Inside the key is basically the element or the token, and the value is the number of time it is occurring. So this is how you get the frequency distribution. Next up is the stop words, guys. So what exactly are stop words? And before that, let me just install the dependencies so that we'll just speed up the process, and we'll just call stop words. All right, one sec, guys. Oh, I was making a mistake, guys. It is actually NLTK dot corpus, and from that we have to get the stop words. All right. So we have installed stop words. So I'll just tell you quickly what stop words actually are. So in computing, stop words are the words which are filtered out before or after processing of natural language data. Okay, I'll just give one variable, let's say stop words is equal to. So in this, I'm just going to show you what all stop words we have. So I have a list of stop words dot all these words in English. So it's going to show me all the list of all the stop words that we have in English. So basically I, me, myself, and all these things that we have. All right. So now I'll tell you how you can remove the stop words from your string, guys. So if I use the same string that is text, so what I'll do is I'll just let's say I'll take new list is equal to an empty list. And now what I'll do is I'll just take one for loop, and I'll just take for I in text, or we'll take the tokenized text, guys, because we already have the tokenized text. So we'll just the sentence that we tokenized, which is A. Now if now we have the conditional statements. So if I not in stop words, which is basically our list of all the stop words that we have in English, we are going to do one thing. So new list is going to append that value, and we are going to print our new list. So let's see. So basically nothing happens. So happiness is when what you think, what you say, and what you do are in harmony. So basically what happened here is all these values that we have in stop words are basically omitted, and we get the clear picture of whatever string that we have. So next up we have is lexical normalization, guys. So I know it's a very fancy term, but it is basically nothing. It reduces the derivationally related forms of a word to a common root word. So we have stemming and lemmatization in this. So stemming is a process of linguistic normalization which reduces words to their word root and chops off the derivational affixes. So let us try to understand this with an example. So what I'll do is I'll just import the dependencies. So from NLTK dot stem, I am going to import a stemmer, and from NLTK dot stem dot wordnet, I am going to import word lemmatizer. All right. So these are the dependencies that I need. Now the next thing that I have to do is I have to make one variable, let's say porter storm, and I'm going to call the porter stemmer method. Right. Now for stemming, what I have to do is I'll just do the same thing that I did with the stop words. I'll take another empty list, guys. So I'll just take it as, say, new text is equal to this, right? Or we'll just write the code over here only. So now what I have to do is I'll just write a for loop for I in. So basically we are going to use the same tokenized text, and now comes the conditional statement. So if I not in stop words, what I have to do is the new text will append the I value, and we will print the new text. Right. So this is what we have, guys. And similarly, if we do it for the next one, that is the lemmatization. So I'll just tell you what exactly lemmatization is. So lemmatization reduces words to their base word, which is linguistically correct lemmas, and it transforms root word to the use of vocabulary and morphological analysis. So lemmatization is usually more sophisticated than stemming, and a stemmer works on an individual word without knowledge of the context. All right, so let's just take this variable. We'll just call it as lemma, right? And in this, I'm going to call the word net lemmatizer, right? So now what I'll do is I'll just take one word, guys. So any word, let's just say we're going to take trying, guys. So this is the word that I'm going to use to explain this. So what happened here is, so I'll just take a is equal to lemma dot lemmatize word and v over here. Do we have an error? So we'll check for an error. If we have any errors, we don't have an error, guys. So now after this, I'll take one more variable. Let's say b. Now porter. What was the variable that we have? Porter stem. All right. So we're gonna call the porter stem, and we're gonna stem the word to it. Now when I print a, we have try. So trying became try after lemmatization, and if we stem it, we have try. So this is what happens with lexical lemmatization, guys. So next up we have the POS tagging, also known as part of speech tagging. So the primary target of POS tagging is to identify the grammatical group of a given word, whether it is a noun, pronoun, adjective, verb, adverbs, etc. Based on the context, POS tagging looks for relationships within the sentence and assigns a corresponding tag to the word. So I'll just tell you what happens when we use the POS tagging, guys. So for this, we do not necessarily need any dependencies. Just you have to install NLTK and import a few dependencies that you already have. So I'll just take one sentence, guys. So let's say my sentence is Virat Kohli is a great batsman. All right, and all right, I'll add a few things, guys, in the Indian cricket history. All right, so this is my sentence. So what I'll do is I'll tokenize it. So using the word token, all right, word tokenize, I'm going to tokenize the sentence. We have like sentences in which we have tokens. So each word will be a token and it will be an element inside a list. So what I'll do next is I'll use the NLTK dot POS tag. So this is basically what I have to call and pass the tokens. So this is how I get the POS tags inside the sentence, guys. So you can get the list of tags, all the tags that you have in POS tags on the official documentation of NLTK. So don't worry, guys. And now that we are done with all these operations, I want to tell you something about the next thing, that is text data transformation. So basically what I want to tell you is these are a few techniques, or you may call it as, the models that we have to prepare the text for data modeling. So the first one is bag of words model. So we obtain the vocabulary list from the corpus and the whole data set. And the length of the vocabulary list is equal to the length of the vector that will be output when we apply the bag of words. So basically bag of words, if let's say if we obtain the vocabulary list from the corpus, and which is the whole text data set, the length of the vocabulary list is equal to the length of the vector that will be the output when we apply bag of words. So that is what bag of words model is. So for each item, I mean, it could be an entry, it could be a sentence or line of text, etc. So we transform the whole text into a frequency count in the form of a vector. And we basically code this by setting up a count vectorizer from sklearn's library, which is scikit-learn, guys. And we fit it on the training data and then transform both the training and the test data. So that is how we work with the bag of words model. And next up we have the word counts with count vectorizer. So word2vec, also it is known as word2vector. It is basically a two-layer neural net that processes the text. So its input is a text corpus and its output is a set of vectors. So the feature vectors for words in that corpus. So the algorithm was created by Google in 2013, and the 50D space. The 50D space can be visualized by using classical projection methods, that is principal component analysis or PCA, to reduce the vectors to two-dimensional data that can be plotted on a graph. And last but not least, we have the word frequencies with TF-ID vectorizer. So this is short for term frequency inverse document frequency, and gives us the measure of how important a word is in the document. And to implement this representation, we use the TFID transformer function from the sklearns library. Fitting occurs on the training set and the values for the same words are determined for the test set. So these are the techniques that we have for text data transformation, or we can call it as vectorization as well. So next up we have the text analytics process flow, guys. So although you can use any model, any artificial intelligence model for classification or prediction, or if you're doing text classification or text generation, there are a number of models that you can choose from. But the basic stuff that goes through inside the whole process is same for everything. So first of all, you have to gather the data. So that is text data acquisition. So you have to gather the data, the relevant data. After that, you have to clean it. By cleaning, I mean you have to tokenize it, you have to remove the stop words, and then you have to lemmatize it and remove all the unnecessary noise that may be HTML tags, sometimes special characters or something like that. And after that comes the next part, which is data transformation, which I've just talked about. That is vectorization, inside which you actually convert it into vectors sometimes. And then comes the part where building model happens. So the building model part is where we use machine learning, artificial intelligence, or deep learning. So it basically depends on what kind of model that we work on, depending on the kind of data that we have. So that is how we choose the model that we want, and after that we do the evaluation and we gather the insights, put it on a visual tool, and that is how we do the text analytics, guys. So now we'll go to Jupyter Notebook again. I'll just show you a simple example of sentiment analysis, how we do it and what goes on inside the whole process. The first step that you have to do is gather the data. So luckily on Kaggle I was able to find out the whole pre-processed data, inside which there was no noise, everything was cleared off, like there was tokenization was done, and you just have to build the model, guys. Just fit the data and you will be good to go. I'm going to use the logistic regression because you'll see when I explore the data that the output is categorical. It's either 0 or 1. So that is how you can go for logistic regression. But my suggestion would be to go for a deep learning model, because that is how you train your model repeatedly on epochs, if you know about it. And it actually helps a lot in the efficiency of your program and improves the accuracy as well. So first of all, I will import a few dependencies I have. So I'll get the training data first of all, guys. So I'll name it as train data. Yes. And pt dot read csv, and I'll just copy the location. So I'll just copy the location over here, right R, so I don't have any truncated errors. And after this, I'll just provide the train data dot csv, and for the same location I have another data set, that is the test data. So I just copy it below this, and instead of train I'll just write test, and same for this one as well. So I don't think I have any errors, so I can take a look at my data, right? So I'll just take a look at the first 5 rows. So I have the reviews in first column. Basically we have the index, after that we have reviews, and then we have the sentiment. So 0 is basically a negative sentiment and 1 is the positive sentiment. All right, guys. So to get a clearer picture, I'll just, all right, guys. So this is how the reviews looks like, guys. And to get the sentiments, this is how the sentiments are. So let's just check the shape of the data as well. And for test data, so basically we have 25,000 entries and we have 2 columns. That is, one is the review column, the next one is the sentiment column. And the next thing that we are going to do is just describe the train data set again. All right, so we have the count, the mean, standard deviation, minimum, and all those values. So these are not really necessary for this data set because it's already normalized and the data is pre-processed. So we'll just move on to the next part, which is basically splitting the data and moving on to the part where we build the model. My suggestion would be you should practice more on the beginning processes, guys, because that is where you will learn how to work with the data. Because in real world, if you are starting out as a beginner, the very first thing that you will be working on in this statistics or any data, you'll have to learn the ELT of data, that is extract, load and transform, guys. So you have to know how to work with the data. Just because I found this data that is already clean and I can just put it inside a model is not the best practice that you should follow, but I'm doing it for the time constraint, guys, because I've already shown you how you can clean your data. You just have to tokenize it, look for the values that you have to remove and any special characters that you can remove, so it'll be good for you. And then you have to transform it according to the shape and everything. And now we'll move on to the splitting the data into the training sets and the testing sets, guys. So I'll just write one comment here like split the data. Now I'll just write train reviews. I'm going to write reviews because we have two columns, that is reviews and sentiment. So I'm going to write it as train reviews, train sentiments and test sentiments. So this is train data and it is denoted by 0, the 0th column. And all right, the test reviews is equal to test data, the 0th column. And again for the train sentiments, we have train data. Now we'll write 1, and for test sentiments we'll write test data 1. So this is it, guys. This is how I split my data. And after this I have to vectorize the data, guys. So I have to vectorize the model, guys. So for that, it is basically word embeddings or word vectorization is a methodology in NLP. We use it to map the words or phrases from vocabulary to a corresponding vector of real numbers, which is used to find out the word predictions, word similarities or semantics. So the process of converting words into numbers is basically called vectorization. So right now all this data is in string format. I'm just going to convert it into numbers. So that is what is called vectorization. So I'll import a few dependencies for this. So I'm just going to use the TF-ID vectorizer for this. So for that, I'm going to have to install from sklearn dot feature extraction dot text. I have to import TF-ID vectorizer. All right, guys. Now I will initialize the TF-ID vectorizer and give it a few values like minimum, right? Minimum difference. So minimum DF, and then there is a maximum DF. I'm going to make it as a 1, and then use IDF is equal to true. And these are the few parameters that you have to give, guys. You can look for the official documentation. They will find all these values that you can put inside this, and accordingly to your data, how your data looks like, you can use these values. Now I will I will get a variable for my transformed training data. So it is basically nothing but I'm going to use this TV that I have initialized over here to give the value. All right, so I'll just get my train reviews is equal to, I'm going to use TV dot transform because I'm transforming the data, which is basically, right. So I'm going to provide train reviews over here, and I'm just going to copy this because we're going to have to use the same one for test reviews as well. All right, and just to make sure that we are doing everything correctly, I'm going to print the shape of these as well. Right, we have an error, guys. So vocabulary wasn't fitted. So basically I made one mistake over here. This is going to be fit transform instead of transform. So now I don't think we'll have any errors. And after this we're gonna have to check the shape of this training data, guys. So we'll wait for it to complete the execution. Alright, so we'll check the shape again, and for TV dot, alright, so we copy this and check the shape for test reviews as well. So this is how I get my shape of all these values after the transformation or vectorization also. So now what I'll do is I'll build my model now. So I'll just give it one comment, guys. So build model. So in this session, guys, I'm just going to show you how you can build your model and then evaluate the accuracy or efficiency of a model. And I'll show you one visualization trick also. I'm just going to talk about the word cloud that we have, which we can use for natural language processing or text analytics. So let's begin with the model selection. So first of all, I'll write sklearn dot linear model, and we have to import logistic regression, guys. So after this, what I'll do is I'll make one variable that is classifier and initialize logistic regression. So now my classifier is ready to fit. I'm going to fit the model and I'm going to provide basically the training data. So train reviews and train sentiments. So this is my training data. I'm going to fit it. So let's see how much time it takes. It is over in no time, guys. Basically I had 25,000 entries and it still took no time to fit the model. Now I'm going to check the predict method, and inside this I'm going to provide the values, that is TV test reviews. So let's check what output we are getting. All right, so we'll give it one variable, let's say predict, and now what we'll do is we'll check for the classification report, but for that we have to import it from the sklearn metrics. All right, so we'll check for the classification report and provide the values which is test sentiments, and then we have prediction. Right, so this is the classification report, and I will write as get the output in the form of a dictionary so that we'll be able to understand this better. So we have the recall, the F1, the support, and the accuracy as well, which is not bad. I mean, for a beginner model it is around 0.69. So a beginner's luck, I would say, if you get a 0.7 accuracy in your first try of your model, that is not bad, guys. But initially starting out, this is acceptable, but later on if you practice more, this should be around more than 90%. So it should be 90% for any efficient model, and even 98-99% accuracy is sometimes not efficient enough for data sets, a lot of data sets. But for now, just to understand how it really works, I'm just telling you, like, this is how you can use the logistic regression model. But instead of logistic regression, you can use the support vector machine, or you can use naive Bayes classifier. You can use the convolutional neural networks, inside which you can give a lot of layers using the Keras sequential API. And for that, you can also use the TensorFlow 2.0 that we have, and it becomes quite easy to work with TensorFlow 2.0 and convolutional neural networks, even recurrent neural networks as well. So this is all, guys, and I'm gonna show you something really cool with word cloud. So word clouds are a popular way of displaying how important words are in a collection of text. Basically, the more frequent the word is, the greater space it occupies in the image. And clean the text and want to see what are some frequent stoppers you want to filter out. So basically, it tells you what are words are occurring in your data, guys. And it is actually a good practice to take a look at this word cloud. It gives you a perspective of what kind of words are there inside your text data, and you can use this to predict values as well, but I would not suggest that because the accuracy is pretty low. It is 0.69, which is not bad for a beginner, but it is actually not good as a model, not efficient enough. Still, I'll tell you how you can predict a few values, guys. So before telling you about word cloud, I'll just tell you how prediction works. So I'll just take one variable review and I'm going to provide some gibberish values, let's say absolute rubbish and never watching it again. All right, so I forgot to tell you guys, this is a movie review dataset that we have, and I'll give the link of the dataset in the description, guys. Don't worry, you can easily find it on Kaggle. So I'll transform it into a vector, guys, because we cannot just use it. So it has to be in a list. All right, so now what I'll do is I'll use my classifier plus predict method, and I'm going to provide this vector, and it is predicting as 0, which is quite surprising for this accuracy, for 0.5969 accuracy. So basically it is telling us that it is a negative sentiment that we have. So until this part where you are qualitatively able to get the sentiments, this is where text analysis ends. For text analytics, you have to figure out a way, or you have to figure out a few insights into your data so that you'll be able to understand why it is that we are getting 0 over here. I mean, why is it a negative sentiment? So for this, I'll just give you a little feedback on this, like how you can use the word cloud to get the words right, you know, the highlighted words in the negative sentences. So we'll use matplotlib for that, and we'll have to import a few other libraries like word cloud. So to use the word clouds, first of all, you have to install word cloud. So if you don't have those, you can just run the command pip install word cloud. So from word cloud, I am going to import word cloud, and I have to import stop words. So this is good, we don't have any errors. Now after this, I will import a few other dependencies. That is, I'm going to import matplotlib dot pyplot as plt. No errors again. So now I'll write plt dot figure, give my figure size. All right, so figure size is I'm gonna give it as 10 by 10. All right, now I will take one variable, let's say negative index, and we will get the values from text reviews, and we will use the index value 5. And now comes the part where we work with the word cloud. All right, and give it a few values like width is equal to, I'm going to give it as, let's say 1000, and then there'll be height I'll give as, let's say 500, and maximum words you have to give, and maximum words, let's say 500 again, and minimum font size I'll give it as let's say 5. So this is all it, guys. Now what I'll do is I'll use the negative words. So now for negative words, I will use wc dot, I am going to generate the words using the wc, that is the word cloud, and now we give the negative text. All right, guys, wait a second, it is not negative text, it is negative index. All right, guys, after this what we'll do is we'll do right plt dot im show, and inside this we give the values negative words. So you want the negative words, and interpolation is equal to, let's say, by linear, and last statement is plt dot show. So let's hope we don't have any errors. And this is what word cloud looks like, guys. So with this we come to the end of the session, guys. If you find it interesting, tell us in the comments which session you want us to do next, and if you have any questions, you can mention them in the comment section below. And don't forget to subscribe to Edureka for more exciting tutorials. Also press the bell icon to get the latest updates on Edureka, and don't forget to check out Edureka's AI and ML certification program. The link is given in the description box below. Thank you and have a nice day.